All the organic reactions we've encountered so far have involved electrons moving in pairs. In this substitution reaction, a pair of electrons from the cyanide nucleophile moves in towards the carbon with bromine attached, forming a new carbon-cyanide bond and prompting bromine to leave with a pair of electrons as bromide anion. Likewise, in this electrophilic addition reaction, a pair of electrons from the carbon-carbon double bond move out towards the H+ end of HBr. This forms a carbocation intermediate, which then reacts with bromide anion, which is bringing with it a pair of electrons to form the new carbon-bromine bond in the end product. We show the movement of pairs of electrons using curly arrows. We've not focused on it before, but there are always two little hooks or barbs at the end of these arrows where they're going to. If we zoom in, you can see two barbs here. This is because these arrows show the movement of two electrons. Two hooks equals two electrons moving. Reactions in which pairs of electrons move together in this sort of a way are called polar reactions. Polar reactions involve nucleophiles and electrophiles combining, electron pairs being shared and redistributed, bonds breaking by heterolysis with one partner getting both electrons, the other partner none. But polar reactions aren't the only major class of organic chemical reaction. There are two others we need to be aware of and learn something about now: radical reactions and pericyclic reactions. Pericyclic reactions, like this one shown here, the reaction of an alkene and a diene, a reaction that's called the Diels-Alder cycloaddition after the people who first discovered it. You can see from the curly arrows shown that this reaction involves three pairs of electrons all moving at the same time around a cyclic transition state. This is the key feature of pericyclic reactions. Multiple electron pairs repositioning all at the same time, always around a cyclic transition state. There are in fact three main classes of pericyclic reactions: cycloadditions, like the one we've just seen, electrocyclic reactions, and sigmatropic rearrangements. More about all of these in due course. The other new reaction class to know about are radical reactions. In this type of reaction, we meet unpaired electrons. Single electrons are moving and repositioning. Bonds break in a homolytic sense, such that one electron goes to each reaction partner. Like polar and pericyclic reactions, radical reactions can be depicted using curly arrows. However, if you look closely, you'll see that these curly arrows are slightly different. They have only one hook or barb at the end to indicate that only one electron is moving. Radical and pericyclic reactions open up lots of new possibilities, which we'll talk about more down the track. For now, the important thing is to be aware of these new reaction classes and to recognize them. Pericyclic reactions for the simultaneous rearrangement of multiple electron pairs. Radical reactions by the movement of single electrons, designated using these single-headed or fishhook arrows.